From torrential rains causing floods and landslides to scorching heat waves taking a heavy toll, extreme weather patterns are becoming frequent across the world. And now a bigger threat seems to be on the rounds. A new study reveals that a vital system of ocean currents could collapse within a few decades due to global warming, and it can be as early as 2025. Scientists say that the collapse of this system could lead to disastrous weather conditions across the globe. But what is this system and how will it have a disastrous effect? Let me explain. Now, this ocean current system is called the Atlantic Meridional Overturning Circulation. It is a vital system of ocean currents that circulates water throughout the Atlantic Ocean. This circulation takes an estimated 1,000 years to complete, but has slowed even more since the mid-1900s. Now, how does this system work? This circulation movement is driven by differences in water density. So the AMOC is like a conveyor belt which transports, or rather carries, warm water from the tropics towards the North Atlantic. This is where the water gets cool and it sinks. It then returns to the tropics and then to the South Atlantic as a bottom current. From there, it is distributed to all ocean basins via the Antarctic Circumpolar Current, which is the most important current, the Southern Ocean, and the only current that flows completely around the globe. Now, how is this system collapsing? As the oceans heat up and ice melts, more fresh water flows into the ocean and in turn reduces the water's density, making it less able to sink. When the water becomes too fresh, too warm, or both, the conveyor belt stops. Now, what would be the implications of the collapse of the AMOC current? Now, since the current plays a crucial role in the climate system in helping to regulate global weather patterns, its collapse would have enormous implications. This includes much more extreme winters in the Northern Hemisphere and decreased rainfall over Europe. Sea level rises can affect parts of Europe and the US, and this could influence the shifting of the monsoon in the tropics. Now, for more on this, we have with us Professor Peter Detlevsen. Now, Peter Detlevsen is a professor of climate physics at the University of Copenhagen's Niels Bohr Institute. Thank you for being with us, Professor. Could you explain to us this vital system of ocean currents, the possibility of its collapse within a few decades due to global warming?
Yes, you gave a very nice explanation of how this works and how it functions. And many people will mistake this for the Gulf Stream, which is also in the Atlantic, but that's driven by the winds. This is driven by buoyancy, as you say, sinking of heavy waters. And if that stops, and the reason that the waters are heavier in the Atlantic than in the Pacific is that it's saltier. So it's the salinity that really is the key feature, and that's why freshwater inflow into the North Atlantic might stop this conveyor. And that could give Northern Europe a climate like what you see on the similar locations in the Pacific, namely in Alaska and Northern Canada, where farming and livelihood is very, very different from what we have in Europe and in Scandinavia, where I am. So this imparts a lot on livelihood, and it's been known for many years that this can happen, and it has happened as long ago as in glacial times, and that's 12,000 years ago. So we are looking into something that we haven't seen in the time of civilization. So.
Right. And Professor, is there a cause for alarm? Sorry to interrupt you, but what would the consequences be if this conveyor belt stopped?
Well, it would be a cooling in Europe, which some projections suggest that farming in England and Ireland and so on would be impossible. We have to compare that with, Alaska or northern Norway. But I think what is more important, since we're in some sense, if we get a cooling here as a consequence of global warming, that seems a little bit contradictory, and the warming might even ease this a little bit. However, this is still an alarm, because the heat that is not transported to the northern Atlantic, in case it stops the conveyor, stays in the tropics. And that's really where you have the big problems in terms of climate change. If the heat stays there, you might even imagine that, like you have in the Pacific, the hot pool around the western part of the Pacific, because it's not transporting in the same way heat northwards or southwards. That's part of the El Nino system, and the El Nino that's building up now is also causing a lot of the extreme heat we see in North Africa and in the Mediterranean right now. So this has big consequences. And the big difference from extremes that you see now and then, and which are unfortunately getting much more severe and much more frequent, as also Guterres was out saying yesterday, this is a switch that will be permanent. It's sort of you're crossing a tipping point, which is like a point of no return. And that means that if you pass this tipping point, you have very, very short time in restoring the climate as we know it, which means that it sets a much stronger pressure in the speed at which we have to do the green transition and stop emitting more greenhouse gases to the atmosphere.
Absolutely. Professor, thank you very much for being with us on the show and for your analysis and very clear explanations there.
You're welcome.
WION, now available in your country. Download the app now. Get all the news on the move.